So there's two types of equations left that we need to talk about. One is equations with radicals in them, and the other is solving exponential equations. So we're going to talk about radicals first. So basically, if we have an equation with a radical in it, like for example, the square root of x plus 2 equals 8 or something like that. In the process of solving this, we'll go back to the same way we started with, just undoing what's been done to x or doing the inverse operations. And you can see here the last thing being done to x is a square root, so that would be the first thing we'd undo. And the way you undo a square root is by squaring both sides. And so when you square a square root, they just cancel each other out, leaving x plus 2. And of course 8 squared is 64. So then I subtract 2 from both sides, and I get x is equal to 62. Now the key here is when I square both sides, there's a potential that I could create a solution that doesn't work. So I always want to check it back there and make sure that it works. If I check an x 62 in there, of course it does work. 62 plus 2 is 64. Square root of 64 is 8. So it does work. Okay, let's do another example of what if I have the square root of x minus 3 is equal to x plus 1. Okay, once again, in this case, I need to get rid of the square root. So I would, and this is a problem though, because notice I have an x on this side and an x on that side. And usually what we want to do is get the x's together, but as long as that x is inside the square root, I can't get those x together. So I begin once again by squaring both sides. So that's going to be the square root of x minus 3 squared. And that would mean that over here I have x plus 1 squared. Of course, the square root of x minus 3 squared would give me just x minus 3. And be careful over here. Remember that x plus 1 squared means x plus 1 times x plus 1. So I'd have to multiply that out. So that'd be x minus 3 over here. And x times x is x squared. X times 1 is 1x. And 1 times x is 1x. And 1 times 1 is 1. So we have x minus 3 is equal to x squared plus 2x plus 1. And now we notice there's an x squared and an x in here, so that means it's a quadratic equation, and I'm going to have to use one of my techniques. That would either be quadratic formula, factoring, or completing the square. So all of those methods require you to get it set equal to 0. So I'm going to subtract x from both sides, and that would give me a plus x, and add a 3 to both sides, and that would give me a plus 4 there. And I can tell pretty quickly that that's not going to be factorable. If I try to complete the square on this one, I'm probably going to get a 1/2. Or I'm going to get a fraction, so I would probably just throw this in quadratic formula. So I get x equals, let's see, negative b, which would be negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c, all over 2 times 1, which is 2. So that would be x equals negative 1 plus or minus the square root of 1 minus 16 would be negative 15. And we stop there and say, oh, wait a minute. I cannot take the square root of a negative number. So this means, as we talked about in class, this means that there's an imaginary solution. But in this class, we're not going to deal with imaginary numbers. So we would just say no real solution. Right? Sometimes we might even have like the square root of x is equal to the square root of x plus 2. So in that case, it's actually set up nicely. You got a square root on both sides. So if I square both sides, it's going to leave me with just x equals x plus 2. And I created another one that's unsolvable. If we subtract x from both sides, notice this time we get 0 is equal to 2, which we know that means no solution. Now let's stop for a second and look at these two. This is no solution. This is, we said, no real solution. So see the difference between the two? No solution, no real solution. Because this actually has solutions. This one actually has solutions, but they're imaginary numbers. But this one doesn't have any solutions. There's not any number that'll work here. Okay? Let's do one more. Square root of x, square root of 2x is equal to the square root of x plus 2. So in this case, I square both sides. I get 2x is equal to x plus 2. And subtract x from both sides, and I get x is equal to 2. Check to make sure it works. It does work. I'm good. Okay, so that's dealing with the radicals. The basic idea is you got to get the radicals by themselves. So like, for example, if I had a square root of x minus 3 plus 5 is equal to 18, I would not square both sides right now. I would subtract 5 from both sides first. So I get the square root of x minus 3 is equal to 13. Then I would square both sides. So I get x minus 3 is equal to 169. And add 3 to both sides, and I get x is equal to 172. And of course, if I check 172 real quick, it works. Awesome. Okay. So that's radicals. You'll also on this next homework, you'll see a few exponentials. So like if I have, for example, 3 to the 2x is equal to 9 to the x minus 1. So normally, we're going to see a lot of these when you get to 141, and eventually we'll use logarithms to solve them. But for right now, we're not going to introduce logarithms. Because there is some of these we can handle without logarithms. So the idea here is if we can get them both to have the same base. So for example, this is 3 to the 2x. I could rewrite this as 3 squared to the x minus 1 power, right? Because 9 is the same thing as 3 squared. And of course, that's the same thing as when you're raising a power to power, you multiply them. So that's the same thing as 3 to the 2x minus 2. And then the idea here is if the bases are the same and these things are equal, that means that the exponents also would have to be the same. That's the only way we're going to make this true. So in that case, we'd have to go 2x is equal to 2x minus 2. Oh shoot, I created another one that's no solution. So I subtract 2x from both sides. I would get 0 is equal to negative 2. Of course, that's not possible. 0 is not equal to negative 2. That's untrue. So this would be no solution. Let me do one that actually works. What if I have 4 to the 3x minus 1, and over here I have 8 to the 2x. Wait, is that right? No, I want that to be 2x minus 1. Okay. So once again, I want to get the two sides of the equation so they have the same base. So I'm going to rewrite this as 2 squared raised to the 2x minus 1 power. And this would be 2 cubed raised to the 2x power. So then if I raise the power to power, I'm going to get 2 to the 4x minus 2 here, and 2 to the 6x there. And once again, since they have the same base and they're equal to each other, that means the exponents have to be the same. So that means that 4x minus 2 has to be equal to 6x. So if I subtract 4x from both sides, I get negative 2 is equal to 2x. Divide both sides by 2, and I get negative 1 is equal to x. So that would be my solution. So again, the idea with these exponentials is just to get the bases so they match, and then you set the exponents equal and solve for that. All right. Try your best at the homework and let me know if you have any questions.